Madam Chairman, Member of European Parliament Del Castillo, ladies and gentlemen, I would like to introduce you to the topic intelligent transport systems and what they can contribute to reducing CO2 emissions. I come from ERTICO, ITS Europe. This is a public-private partnership organization which was created in 1991 to promote the effective deployment of intelligent transport systems in Europe. Now, what are intelligent transport systems? In a nutshell, what intelligent transport systems are, these are systems where first you collect data. You collect data via sensors within vehicles, via your smartphone. There are lots of opportunities where you can detect and collect data. Then you exchange the data, you're processing the data, and then you bring it to a user, you bring it to some use. Now, what we see are actually three major trends in the context of intelligent transport systems, which lead to what we call mobility as a service. And mobility as a service, I think this is what we see as a vision at maybe the end of the tunnel. And mobility as a service means that the customer, that can be the traveler, that can be a logistic operator, he gets a service for his mobility needs from end to end. He gets it from one service provider, he gets it with one contract, he has to do one reservation and booking and payment. But there are five major mosaic stones which bring us to what we call mobility as a service. And the first one is connected and automated driving. Connected and automated driving means that vehicles can exchange data with each other, and vehicles can exchange data also with the infrastructure and also with traffic management centers. And this makes already, this data exchange, this information exchange, already supports that it makes transport more efficient. Because, first of all, it avoids accidents, and accidents cause then also congestion. It also supports traffic management with information which is then real time, so that we can route the vehicles in a more efficient way. And it also helps with navigation, the driver itself, to reroute whenever there is congestion and there is a problem on the road. Now, with automated vehicles, there not only the driver will get information, but the information will be used by the machine itself. And that will make transport even more safe, but it also will create a situation where we can organize transport in a much more efficient way. We will, at the end, we will automate transport itself. Then there's the aspect of e-mobility. And you know that we have this trend where also the political will that we should have more electric vehicles on the road. But for electric vehicles, the challenge still, maybe also in the foreseeable future, will be that the range of the vehicles is limited. And their intelligent transport systems provide the information that you know that you can go from A to B with what you have in electricity in the car. It will also support the linkage to other modes of transport, and it will support the integration into the electric grid, so that you get the information where is the next station for your electricity. Also, electronically, there will be the reservation, there will be payment for the services you need for your electric vehicle. Then there is ITS for freight transport and logistics. And there again, we are working towards synchromodality. That means that there is co-modal transport of goods, and the different modes of transport are in an optimal way organized. And this is only possible when you have the right level of information for the logistic operators at each moment in time. And then there is pre-active traffic management, And preactive means that you're not only informed about the situation on the road, but you can also predict certain developments and avoid them maybe from happening, like congestion. And we have more and more new mobility services like car sharing. Now I would like to provide you with some figures. And that is really some of the most challenging parts of our work. Because we are again and again asked also by politicians who say, what do we really get out in a quantitative way? But it's very, very difficult on the topic of intelligent transport systems really to come up with quantifications because all the circumstances are different. When you look at cities, when there's introduction of ITS in cities, each city has different problems and challenges, and the impact of the deployment of ITS is different. But we have done and studied together with the European Car Manufacturing Association, ACEA, where we looked at scientific evidence with respect to some applications which are currently already on the road, and looked at how much are the CO2 reductions which are achieved by these applications. First, and I give you now only two examples. First is eco-navigation. And eco-navigation has the aspect of dynamic navigation where you avoid congestion and any problems on the road. And it has the aspect that you get information about what is the most CO2 efficient road. And there, the potential of CO2 savings are already between 5 and 10%. And that is really a big figure for transport. Now a second one which I would like to introduce is green light optimized speed advisory. And that means that you are on a road with traffic lights, and that the traffic lights react to the traffic situation, so that whenever possible and when it's useful, they give you a green wave. And at the same time, they also give an information to the driver when it will become red, when it will become green, and give advice in the context of fuel-efficient driving. If you should accelerate, if you should decelerate. And here the potential CO2 savings are 15 to 20% on average, but only in the context when you have these traffic lights. So it's not for your whole trip, it's only when you have the situation with traffic lights, for instance, in cities, then you have these quite substantial fuel consumption reductions. Now we are also working with the European Car Manufacturing Association now on a new study, and this study will be on truck and buses. And then maybe I would like to introduce you to one example, and that is about truck platooning. And you know that the current EU presidency, Netherlands, they have made a truck platooning challenge to promote this technology which allows trucks to drive very close behind each other, which has an impact on efficient usage of the motorways, it has an impact on safety, and it has an impact on CO2 emissions because it improves the efficiency because you have less air resistance. And there are already figures concerning the truck platooning, which give us a saving potential of between 8 and 20% concerning the fuel emissions. Now, I would like to finish my short statement with maybe for the ICT industry a more strategic thought. And that is, I believe that the ICT industry for a long time was maybe more supply-oriented than demand-oriented. The technology improved and improved, and you could provide better and better services, but the services were mainly about voice and maybe SMS. Now with data, I think now you start in a very intensive way to listen to other sectors, and you want to learn what are we the other sectors needing in the context of connectivity, so that we can provide our services in the context of our sector. And there my message to you is that connectivity and also what we call big data will be of highest importance for the future of mobility. And what we really see is a disruptive change of mobility in the future. And there we need the right level and appropriate level of connectivity and data processing in the future. Thank you very much for your attention.